Okay, here we are with part 2 of our Basics of Geometry's notes. We're continuing on filling out these vocabulary terms. Again, you see the term here on the left, definition, and then I'll be giving examples as well. So the word collinear. Collinear means a group of points that line up. Co means together. Linear means line. So collinear is together on a line, okay? So here, if we're looking at points A, B, and what line up, that would, of course, be point C. A, B, and C line up. Those would be collinear. Now, the not collinear lines, or not collinear points, would be like A, B, and D. You see, D does not line up, okay? All right? Now, here's a trick question, guys. I'm going to say this, and we'll talk about it later. If I asked you if point A and point D were collinear, the answer would always be yes. Answer would always be yes, because you can always draw a line through any 2 points, okay? That's important. So in order for them to be non-collinear, they have to be 3 of them. 1, 2, 3, because if I asked you any of these 2 points, like AD could have a line going through it. BD could have a line going through it, because through any 2 points, you can always draw a line. We'll talk about that more here in just a second, okay? So now we're talking about coplanar points, all right? So coplanar, together on a plane, a group of points that lie on the same plane, okay? So when we're looking at the flat surfaces that make up this cube, top, bottom, left, right, front, and back, yeah, those are all thinking about individual planes, okay? So points A, B, C, and D would all be up on this top surface, yes, so those would be coplanar, but then we could mix in one on the bottom like A, B, C, and F. F would not be coplanar. A, B, C, and D are all together up top, but F is down on this bottom surface or the back or the side. It does not part of the same plane, okay? So that would be non-coplanar. Now, just like we just had with any 2 points you can draw a line through, any 3 points you can always have a plane, okay? So if I asked you, like if points A, points C, and point E were on the same plane, the answer would be yes. And the reason is because they're 3 points that are not in a straight line. They can always be on the same plane. Imagine like we dropped like a piece of, like if this was a box, we put in a piece, one piece of paper here that would make a plane. That would be this flat surface cutting diagonally across my box. Does everybody see that? Okay. So yes, those would be on the same plane. That would be like a diagonal insert into this box. So any 3 points, you can always draw a plane. Those are trick questions, okay? So a line segment, moving on, line segment has 2 endpoints and can be part of a line. Again, it's just part of a line. So when we're drawing it, it looks just like a line, except it's going to have endpoints, not arrows. Arrows means it goes on forever. That's a line. A segment has endpoints, okay? Now, when we're naming this, order does not matter. So what I could name this, it would just be line AB, okay? Line segment AB, because again, no arrows, or line segment BA, okay? The order doesn't matter. Order does not matter when naming a line segment. Same thing for a line, okay? Now, a ray is a little different, okay? It has 1 endpoint and extends forever in the other direction, okay? So when we're drawing that, it starts off with 1 endpoint, it goes out, and then it goes on forever. So we have 1 endpoint and 1 arrow, okay? So if we call this like A, and I'm gonna put another point on here, B, okay? The way I would name this is ray AB. Again, I drew the ray above it, just like we drew the line segment or the line, but this is a ray. Then this is telling me, guys, that my ray started at A, went through B, and then on forever and ever. So that's the situation here. If we drew ray BA, that is incorrect. This would not work because this does not describe what's happening here. The ray does not start at B and go through A, so that's wrong. That is not good there. That is a non-example, okay? All right, last one here, and this is a pretty straightforward idea, guys. If we have what are called opposite rays, if you choose a point on a line, that point determines exactly two rays called opposite rays. So if I picked point B, yes, of this line, technically we have one ray going this way, one ray going this way. So if we have opposite rays that extend out from point B, then really we're just creating a line. So again, ray BA and ray BC are opposite rays. And again, I had to start at B. That's the one I picked, right? I picked B and it went through A on forever. Same thing, went from B to C on forever. That's how I named them, okay? You got to be careful there. So now a couple more examples here, guys, all right? Are points P, T, and M collinear, okay? So P, T, and M, are they collinear? Are they together on the same line? Well, P, T, and M, no, they are not. Why? Are they collinear? No. No, they're not on the same line. All right, and again, I'll keep my explanations here pretty brief, okay? No, they're not collinear because they're not together on the same line, all right? So here's a trick question. Are points A, F, and B coplanar, okay? Well, we look, we see A is over here, F is over here, and B's up top on this other plane, this vertical. So we have a horizontal plane and a vertical plane. Are they on the same plane? Well, the wrong answer would be no, they're on two different planes. The right answer here would be yes, they are always coplanar, guys, because any 3 points, you can always draw a plane through them. So yes, this is that trick question I was talking about. You can always draw a plane. You can always draw a plane through any 3 points. Any 3 points, okay? Now, any 3 points will work, but again, like we said up here, we can't name them, okay? Or well, the first page, we can't name them unless those points are not in a straight line, okay? So, through any 3 points, you can always draw a plane, okay?